Good morning, Poland. How are you feeling today? Oh, hungover. Very well. Small inventory first. Who in this room sells IP transit services to its customers? Raise your hand. A few. And who of you explicitly filter on these customer sessions all the prefixes based on IRR? Oh, the same few people. Very well. Because today I want to talk about the IRR system, a certain tool I've wrote, and how we can make the most of this ancient mechanism to communicate to each other which routes you will announce. Introduction. My name is Job Snijders. I work for NTT Communications. Our only product is IP transit, hence my interest in routing security. I'll start with explaining what IRR is, what issues are with the current systems as we know them, a proposed mechanism to make more of this weird data that we have in these databases, and a new tool that is there for your benefit to assess the state of your current IRR objects. The IRR system stands for Internet Routing Registry. And it is basically a mechanism where you can upload a snippet of text to a server, and other people can query that server to see what you uploaded there. And the intent 20 years ago was very well. People would trust each other. Everybody thought back then, people will not upload garbage. Everybody cares about the internet. But fast forward 20 years, we've noticed that there is no incentive for people to clean up old garbage in the IRR system. There are many databases that do absolutely no verification whatsoever, so they are inherently insecure. And the RPSL language in which route objects are described has a gazillion features, and only a percentage of them is actually used in real life. So it is not the perfect mechanism anymore. But there is still stuff to salvage. If we look at what IRR means in terms of security, there are a few incidents in which spammers would register blocks of unused IP space in RADB or in different databases. The transit providers of those spammers, who didn't know they were spammers, would generate their prefix filters, upload those to the routers based on IRR data, and accept these prefixes that were not belonging to the spammers. But the transit provider did not know this because there was no authentication. So it is worth trying to lock down on this principle of IRR databases and try and make it more secure to prevent incidents like these. In essence, what an IRR lockdown is where we say we will only honor route objects when they come from the appropriate data source. For instance, we will only honor route objects that cover RIPE address space if they come from the RIPE database. And we will ignore all route objects that cover the space belonging to that particular regional registry if they do not come from the same database as where they... Wait, this sentence is a clusterfuck. Let me try again. If you put RIPE space in RADB, you're putting it in the wrong database, and I propose you just ignore those route objects. That's, in essence, an IRR lockdown. And this can work for the following reasons. Long ago, IANA, which is the holder of all address space, they started assigning chunks of space to the various RARs, like ARIN, RIPE, LACNIC, etc. And there are differences between all these RARs. Some IRRs have an internet routing registry which is not linked to the same database as in which they administrate who the owner of space is. And it is very hard to authenticate data if it's two separate databases, one with who the owner is and one with the route objects. Some IRRs offer mechanisms that when they make you authenticate objects properly, they will assist you in that process, and if there's not enough authentication, they will, for instance, reach out to all relevant parties and help them along the process. Not all IRRs have 24/7 support. And in this regard, RIPE is a very special database, because in RIPE's database, the owner of the IP block and the authority to create route objects, there is a chain of trust between those. In other words, for route objects in the RIPE database, I have very strong guarantees that the owner of the IP space actually approved this route object. So knowing that RIPE got from IANA roughly 35/8s, why would we not stop accepting route objects covering those 35/8s from different sources? In other words, put your route objects in RDB, and if they cover RIPE space, I'll ignore them. If you put them in the RIPE database, where I have very strong guarantees this is actually approved, then I will accept them. If you look at the IRR system, what in essence happens, we have a service called rr.ntt.net, and this is an instance of software that communicates with different IRR databases. And untrusted IRR updates would be, for instance, the daily dumps that our software loads from different IRRs, or there's a protocol called NRTM. This is a protocol between internet routing registries on which they replicate the data which they received from their end users. So what we can do on this rr.ntt.net instance is that anything covering RIPE space, but that does not have the source field for RIPE space, that we just ignore them. The benefits of this are manifold, in my opinion. Today's filters are hard to trust because anybody can put anything in a lot of databases, and the whole mechanism is as strong as the weakest link in the chain. So if there is an internet routing registry that will take any route object as long as you pay them $100 per year, then anybody can get into any filters. This approach does not solve everything. This approach only locks down the 35/8s that RIPE assigns to its members. But that's better than nothing. It just becomes harder to hijack RIPE space in this regard. And doing something is better than doing nothing. If I look at statistics that I collected 10 months ago, if we were to deploy a mechanism like this, if we were to say, we are no longer accepting prefixes covering RIPE space if they're not registered in the RIPE database, my estimate 10 months ago was that roughly 1,000 prefixes would be impacted. And if I look at what's actually in our customer base, that number goes down to 500 prefixes that are impacted. And this is, in my opinion, very good news, because 500 prefixes is small enough amount to literally get on the phone and call each of those customers and tell them, look guy, you need to move your route object to the RIPE registry. If this number would have been, say, 10,000, I would not be on this stage. I would not be able to pull that off and call 10,000 organizations. The point is, this approach from a statistical perspective could be viable. To give a very solid example, IANA assigned to the RIPE registry 193/8, and it is RIPE's function to assign smaller chunks of that space to its members. On the left side, we have a proper route object. This route object has as origin 333, which is RIPE's office building. This is the prefix they assign to their office building, and it is maintained by the RIPE NCC maintainer. So for this route object, I have very strong guarantees that this is actually what the RIPE office staff intended to do. And it's stored in the RIPE database, of course. On the right side, we have a route object that under normal circumstances will be honored, because people do not differentiate between where space should be registered. And what we can see here is that some rogue assailant put in 193/21 with a different origin, 666 in this example, and it is stored in an entirely different database, the RADB database. And my question to you in that regard is, why would we ever honor route objects for which we have no certainty at all that they are actually valid or not created by malicious people? Let's skip over this one. Now, I've done a lot of blah, 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 and it might sound a little bit theoretical, but to help you understand the impact of filtering strategies like IRR lockdown, I've created a tool online called IRR Explorer. And you can see the hardest part was getting a nice logo. It is important, I think, that people can easily test for themselves or for their customers or refer their customers to a neutral central location in which people can get an overview. How are my route objects doing? Are they in the appropriate database? Did I even register them or not? I grew tired of endlessly typing CLI commands, and that's why I thought we should have a fancy Web 2.0 web interface. If you go to irrexplorer.nlnog.net, you get the web interface. It is all open source. It's available on GitHub. So if you're familiar with Python or feel like doing some jQuery, please join our effort. What IRR Explorer in essence does is it real-time tracks all internet routing registries that are of relevance. This means NTT Com, RIPE, ARIN, RADB, AltDB, and a bunch of others. It takes in BGP feeds from the NLNOG ring looking glass. It throws that through a blender of sorts, and out comes a very nice data set which you can access through the web interface. A little bit of credits. It took roughly 300 hours to build this tool, and in particular I want to thank Henrik Toestrup Jensen from Nordunet, who made the tool extremely fast, because when I launched this tool in May, it was slow as hell. It was a super multi-core machine, and it was just crunching away on my inefficient, dirty code. And this guy said, "Look, Job, your code is terrible. Let me rewrite half of it." And this is the result. If you go to this web interface, you can input either an AS set, your AS number, an IP address, v4 or v6, or a prefix. If we put in the IPv4 address for PLNOG.pl, this is the result. We can see that apparently this belongs within a /20. The /20 is visible in BGP with origin AS 50481. It is registered in the RIPE database. It is space managed by the RIPE IRR. So my conclusion is perfect. A+. But the software also looks for prefixes that are related to the IP address or the prefix it found earlier. And what we see further down is that multiple more specific prefixes within this /20 have been registered in the RIPE database, but are not visible in BGP. Now, this in itself is not a bad thing. Maybe this is for scheduled maintenance or scheduled traffic engineering purposes, or maybe the customer has yet to set up the BGP sessions. But it is worth looking at objects like this. Does this need to be in the registry, or do I need to clean this up? Different example from my colleagues at the Neutral Internet Exchange in the Netherlands. Their website is hosted at this IPv4 address. And here we have far more interesting results. There's all kinds of /24s related to that IP address. What the engine does is it will look at the largest subnet in which the IP address fits, either in BGP or in IRR, and then it lists all more specifics from that fall within the largest subnet. And here we see, for instance, there's a /24. It is visible in BGP. There is an AS originating this /24, but it is not registered in any IRR, and it should be in the RIPE database. And if stuff is red on this page, you can just tell your customers, look, just keep working until everything is green. And people, you know, from their video game experience as kids, they know that red is bad, green is good, and they won't bother you anymore until they fix it. At least that is my ambition. I don't know if this is true in reality. Different example, here we put in AS 15562, which is my personal AS, and we see that some of the space related to this AS is managed by RIPE. Other space is not managed by RIPE. And again, for each prefix there is advice ranging from perfect registration to red, which in this case there's a prefix in the DFC, no route object anywhere with the correct origin AS. This would mean if I'm a customer of NTT, chances of NTT not accepting this prefix are very high. I purposely built it this way, but your customers or partners might not have known that. And if you're wondering, why is this transit provider not accepting my prefixes, IR Explorer might give you some insight whether there are registrations or not. If you scroll down on the AS page, if you search for an AS, it will also show you which AS sets your AS is a member of. There might be some surprises there. Maybe you're like, why did that guy put my ASN in his AS set? That doesn't make sense. He should remove it. Or maybe you're like, fine, this is exactly what I expect. You can input AS sets in the system. If you present to your upstream providers an AS set, you can analyze the AS set by putting it in IR Explorer, and it will show you the expansion of that set into all its members. And this ultimately, if you have RIPE space, is what you should strive to get to. If the prefix is RIPE managed, the advice should just say perfect. And if it's any variant of perfect, either it's legacy route objects or route objects that you didn't know exist, or something else. If we look in terms of timeline, what I recommend is start using IR Explorer today. Take a look at how your prefixes are registered or not. Fix that. Work with your internal departments to properly register RIPE space in the RIPE database. And in terms of the filtering strategy that I mentioned in the earlier part of my presentation, if we feel comfortable enough with this mechanism and that it won't do too much damage, then we look at deployment in, say, the second quarter of 2016. We are not alone at NTT in this strategy. There's a company in Germany, Optimax. They already do this today. The EKEX route servers in Germany, they are considering to deploy IRR lockdown as an additional filtering mechanism on their route servers. NTT is considering deploying this filtering mechanism. And anybody that generates route filters using rr.ntt.net, which is a free public service to query the IRR, will automatically start using this if we implement it. And I hope that you, if you're a transit provider, will use this mechanism as well. And if you're a transit customer, at least ensure that your route objects are registered properly, because that makes our life much easier. Are there questions so far? Now's your chance. Well, thank you for your time, and I'll see you at the coffee break.